Business Calculus, Topic 5, Homework Problems number 16, 18, 19, and 20. We want to take the antiderivative of these functions here. So I'm going to use substitution rule. Here I'm going to let my u equal negative x minus 3. My derivative of u will then be the derivative of negative x, which is negative 1, negative 3 is 0, times dx. So this means I need a negative 1 dx here. So let's include it. So here's the negative 1 right there, and then negative x minus 3 all to the 6th power, and then dx. And the reciprocal of the negative 1 that I added here will go out here. The reciprocal of negative 1 is negative 1. Alright, so this portion right here, the negative 1 and the dx, that is represented by du. This portion right here is represented by u. So this is u to the 6th power with the negative 1 on the outside. So now, the antiderivative of u to the 6th power will be u to the 7th power times the reciprocal, 1/7, with the negative 1 still out there, and then plus c. Now, the u, I will make that back into take that to negative x minus 3 to the 7th power plus c. And this is our antiderivative. Okay, here, I'm going to move my 7.4 to the outside of this function, leaving the e to the negative 6x plus 7 power dx. And I'm going to use substitution on here. I'm going to turn this into u. So u equals negative 6x plus 7. And the derivative of u will be the derivative of negative 6x, which is negative 6, derivative of 7 is 0, times dx. So this means I need a negative 6 in here. So I'm going to put a negative 6 there. So I have a negative 6 in dx. But I'll also put the reciprocal out here, negative 1 over 6. So now, these two combine, I get my negative 7.4 over 6, and here, this portion right here, these two, they become my du, and the e to the 6x plus 7, all this becomes u. So this is e to the u. So the antiderivative of e to the u is e to the u plus c. And I can simplify this to negative 7.4 over 6. Sorry, I return the u to the negative 6x plus 7. Negative 6x plus 7. And then plus c. Okay, here once again, I'm going to remove the constant 2.7 to the outside of the function. 2.7. And that'll leave the e to the 0.9x plus 3 power dx. I'm going to consider this as my u. So u is it's 0.9 x plus 3. This makes du 0.9 dx. So I have a dx, but I don't have the 0.9. So I'll put a 0.9 here. And together, that becomes my du. But the reciprocal of 0.9 is 1 over 0.9 here on the outside. Okay. This together gives me 20. I can move this over. I can get 27 over 9. And here, this becomes e to the u and du. The antiderivative of e to the u is e to the u. 27 divided by 9 is going to be 3, and then plus c. So this all becomes 3 e to the u, which represents 0.9 x plus 3, all plus c. Okay, for this one, I'm going to move my constant to the outside, so we'll get 6.3. And I'm going to convert my root here to a fractional exponent, so negative 3x plus 4, all to the 1/2 power dx. Okay, now I'm going to count this as my u, so u equals negative 3x plus 4. This implies that du equals negative 3 times dx. So I have my dx here, but I don't have a negative 3, so let's put a negative 3 here, and the reciprocal, which will be negative 1/3 there. Alright, so these two become 6.3 all over 3 with a negative, and this becomes, this is du, this becomes u to the 1/2 power du. Okay, 3 goes into 6 2 times and 0.3 1 time. Okay, the antiderivative of u to the 1/2 will be u. I add 1 here, I'll get 3/2, and the reciprocal of 3/2 is 2/3, and then plus c. Alright, the negative 2.1 times 2 is negative 2.4 all over 3, and this will be, instead of u, this will be negative 3x plus 4 raised to the 3/2 power plus c. Now, I can keep this way and it'll be fine, but I can simplify a little more. 3 goes into the 24 8 times, and I can return this to a root, which will be the square root of the negative 3x plus 4 raised to the 3rd power, and then plus c.